Hi, everybody. It's Miss Austin, and I'm going to be going through some of the homework problems with you. We're starting with the problems in your book, the Unit 3, or excuse me, Unit 2, Lesson 3, and those start on page 187. So we're going to start with number 1. It says triangle ABC is congruent to EDF. I'm actually going to write that out for myself in a congruent statement so I can see where the corresponding letters are. So Kieran knows that there is a sequence of rigid motions that takes ABC to EDF. Select all true statements. And once they've made this statement, I don't even need the picture, but it might help. So does angle A coincide with F? Well, let's just look at the statement. A is the first. Is F the first letter over here? No, they do not coincide. B coincides with D. B is the second to the second. Yes. Segment AC coincides with EF. AC coincides with EF. Yes. Segment BC coincides with ED. BC is the second to the third letter, and then this is the first to the second. No. And finally, E segment AB, that's the first two, coincides with ED, the first two. Correct. Okay, you could also look at the shape. I find that once the congruent statement is made, it's easy to just look at the way the arrangement of the letters. Number 2, a rotation by angle ACE. So that's this angle right here. So they took this shape, rotated it, using point C as the center, takes triangle CBA to CDE. CBA to CDE. So imagine this rotating onto that. Okay, we could get tracing paper if we wanted. It says, explain why the image of CA lines up with CE. Let's get a piece of tracing paper. Okay, we're going to rotate it this much. And I better put letters on it here. C, A, B. Here we go. Whoops. So we can now see that CA lines up with CE. It says explain why. Well, that's the way we defined it. We defined the rigid transformation as a rotation of angle ACE using point C. They line up because we defined it that way. Explain why the image of A coincides with E. So one more time, when I rotate that, because we define that, it's a rigid transformation, so that A is going to coincide with E. Because it's a rigid transformation that takes A to E. And last, is triangle CBA congruent to triangle CDE? Explain your reasoning. The definition of congruence is if you can find a transformation or a series of transformations that maps one shape onto another, then they are congruent. We just defined this being mapped onto this through a rotation, which is a rigid transformation. Yes. Since we rotate triangle CBA onto triangle CBE, they are congruent. The definition of congruence is if you can map one figure onto another through a transformation or a series of transformations. Okay. Number 3, Oh no, we're skipping 3. On to 4. It says triangle HEF is the image of triangle FGH after a 180-degree rotation around point K. Let's just visualize this. Here's FGH, and I'm going to rotate it 180 degrees. It doesn't matter which way I go. So F is now over here, G is here, H is here. Okay? And they also, again, the congruent statement, it says EFH is the image of FGH after rotation, which means they're congruent. Triangle FGH is congruent to triangle HEF. Because this is mapped onto this through 180-degree rotation, which is a rigid transformation. So it says select all that must be true. Triangle HGF is congruent to FEH. So they go HGF, which let's look at the way I wrote it. So it goes backwards. HGF goes to HEF. That would have to go, oh, sorry, to FEH. I was looking at the next one. HGF, to FEH. Yes, they just reversed the order. GFH. GFH is to, would have to be, E would have to be first, wouldn't it? Because G corresponds to E. G, first one on the next one would need to be E. No. Angle KHE. KHE, that's that angle right here, is congruent to KHG. KHG. We did this in another homework problem. I want you to watch the angle, okay? I want you to watch this angle right here. I'll color it. They want to know if that angle is the same as that one underneath there. I'm going to rotate it. That angle ended up over there. These two aren't congruent. No. Angle GHK, that's this one, is congruent to EFK. EFK. Yeah, that's what we just did. We saw that one already. Segment EH is congruent to GH. Now here we could look at our figure. We could use our letters. EH is these two to GH would have to be G, middle to the first, middle to the, no. Segment HG is congruent to FE. Let's see if the segment HG, last to the middle. This one is a little different though, because when we're talking about, even though, I better go check the last one. I might have made a mistake on that. GH, right, is congruent to EF, but you can say a segment in the reverse order. So those two actually are congruent. If you're just saying a segment, you can say it. Let me make sure I didn't mess up on that one. EH to GH, no, because this one is congruent to this one. We could say FG or GF. And then the last one it says is FH congruent to HF. Yes, that's that centerpiece. It's the bottom maybe or the top. No matter which triangle, it's the same length in both triangles. Okay, moving on. That was number 4. Number 5, it says line SD is a line of symmetry for figure ASM, HZDPX. Tyler says, so this is the line of symmetry. Tyler says that ASDPX is congruent to SMDZH because sides AS and MS are corresponding. Why is Tyler's congruent statement incorrect? Well, once he starts talking about one shape, let's look at this. He starts with this one. He says AS, so he goes here to here, then up that symmetry line, then to P, then to X. Okay? So AS, D, P, X should be congruent to, that should start, let's use a different color. That should start here, come to here, go up the symmetry line, go down and here. Okay, so it's going this way. So what should it be? Well, I'm actually going to answer B first. I think that part's easier. So it should be what? M to S to D to Z to H. Now let's look at Tyler's. What does he say? He says SM. That is true. This segment is the same as this segment. And those two are congruent. But when you're talking about the whole shape, you have to give the corresponding points in the right order. So his mistake is that he said S first when he should have said M first, because M and A correspond to each other. So M and A are corresponding, not S and A. Oh, I can't see my writing, sorry. And then the correct statement is right here. We already made it. I'm just going to arrow right here. He said S to M. Should have been M to S, then to D. All right, number 6. Triangle ABC is congruent to triangle DEF. Select all true statements that are a result of corresponding parts of congruent triangles being congruent. So once we know two shapes are congruent, all their corresponding parts are the same. I'm going to write that statement. ABC, triangle ABC is congruent to triangle DEF. You can look at the shape, you can look at the statement. AC, that's this one, is that the same as EF? Hopefully you can tell from the drawing now. And also look, AC is the first to the last, and then EF is the middle to, no, they're not in the same order. BC, last two to EF, last two. Let's look here. BC, that's this one, to EF. Those two look right, yes. And you could tell from the statement. Angle BAC, BAC is congruent to EDF. Hopefully you can tell from the drawing, but let's look at the arrangement of the letters. They go middle, first, last, middle, first, last. Yes. Angle BCA, BCA is congruent to EDF. That's this angle again. Is that angle the same as that angle? No. You could also look at the letters. Middle to the last to the first, middle to the first to the last. No. Angle CBA, CBA, that's this angle, is congruent to FED, FED. Let's look at the arrangement of letters. Hopefully maybe you can already tell it's true. Last to the middle to the first. Wait a sec, did Miss Austin do this backwards? CBA, FED. Oh yeah. We're going backwards. CBA, FED. Yes. I don't know why I thought that wasn't right. That's number 6. All right, moving on. And we got one more left. We're going to do number 7. It says when triangle ABC is reflected across line AB. So they reflect that triangle over to here. The image is triangle ABD. So that's a rigid transformation. So ABC is congruent to ABD. Why is angle ACD congruent to ADB? Let's read all the reasons. Corresponding parts of congruent figures are congruent. Congruent parts of congruent figures are corresponding. Segment AB is perpendicular bisector of segment DC. An isosceles triangle has a pair of congruent angles. Definition of congruent is when one figure can be mapped onto another through a transformation or a series of rigid transformations. The shapes are congruent. This is the image after a reflection. Therefore, these two shapes are congruent. Once you've proven two shapes are congruent, all the corresponding parts are congruent. That means this side's congruent to this side's congruent to this side's congruent to itself, this angle's congruent to this angle. You get the idea. So hopefully you can tell that A, because corresponding parts, these two correspond to each other. Corresponding part of congruent figures, these two are congruent. Since they're corresponding and they belong to congruent figures, they are congruent. Okay, that's the end of the lesson 3 problems. The next video will pick up for the lesson 4. Hope that helped.